Today we will be in Chapter 9, Section 3, Solving Systems of Equations by Elimination. Our topic objective for today is to solve systems of equations by the addition method. Okay, today in 9.3 we are going to learn how to solve systems of equations by using the addition method. Our goal whenever we are doing these problems is to obtain two equations whose sum will be a single equation containing a single variable. That might not make sense yet, and that's okay. I am going to do nothing but work through problems today, a lot like 9.2. So hopefully you will see what I mean by that. And again, I'm going to give you all the steps first, and then I'm going to work through a whole bunch of problems so that you understand how to use these steps. So if you don't understand the steps right off the bat, that is okay. You will by the time you're done with all of this. Okay, so the steps for how to do systems of equations using the addition method. Step 1, you're going to rewrite all equations to look like ax plus by equals c. Step 2, you're going to multiply one or both equations by a constant so as to eliminate one variable through addition. Again, that sounds a lot more complicated than it is. We'll do a whole bunch of examples. Step 3, you're then going to add the equations. Step 4, you're going to substitute the value obtained in step 3 into one of the original equations. And then step 5, you're going to solve for the unknown or remaining variable. So I'm going to give you a few seconds to write that down. Luckily, some of these problems you won't have to do all of these steps. In our first example, you won't have to do the first two steps at all. So some of these you just do if you have to. Okay, I'm going to go ahead and work an example. If you need to, obviously you can pause the video to write down those steps. Okay, our first example is x minus 2y equals 9. And then our second equation is 3x plus 2y equals 11. So step 1 says to rewrite them, but they already look the way they're supposed to, so we don't have to rewrite them. Step 2 is the step that can be confusing whenever you're just reading it. So it says to multiply one or both equations by a constant so as to eliminate a variable through addition. So what that means is if we're looking at our equations, we have an x and a 3x. So if we were to add those, would the x's go away? No. But we have a minus 2y and a positive 2y. So if we were to add those together, would they go away? And the answer is yes. And if they do that, then we don't have to multiply either equation by anything. So I'm going to draw a line, and we're going to do some vertical addition here. So if we have x plus 3x, that will give us 4x. If we have a minus 2y plus a positive 2y, that's going to leave us with nothing, so I'm just going to leave a blank. We have our equal sign, and then a 9 plus 11 will give us 20. This is what it means by the addition method. We are adding our two equations in order to eliminate one of the variables. We got rid of our y's. They went away. So now we have our 4x equals 20. So we need to solve for our x. So we have x equals 5. Now that we know what our x is, we can plug it in to either one of our first two equations and then solve for our y. So I'm going to plug it in to this first one. So we have x minus 2y equals 9. So anywhere there's an x, I'm going to plug in 5. And then I'm going to solve for my y. So give me 2y equals 4. So y equals negative 2. So that means my ordered pair would be a 5, -2, and that's my answer. Let's do another example. That one is obviously the easiest type of problem you're going to have because it was already written in the way it was supposed to be, and you could automatically just add and one of your variables disappeared. And that's what you want to happen. So let's do one that's slightly harder. Let's do 3x plus 2y equals 6, and an x minus y equals 8. Okay, these are already written in the way they're supposed to, but if we look, 3x and an x, those will not eliminate each other, and a 2y and a -y, those won't eliminate each other. So we're going to have to do that step 2, where we're going to have to multiply one of our equations by something. If we look, both of our x's are positive, so if we add those, they're just going to combine. But if we look at our y's, we have a positive y and a negative y. So that means if we were to add them, potentially they could be eliminated. So I'm going to multiply this whole second equation by 2. And when I do that, that's going to give me a minus 2y here. And then I'll be able to eliminate them. So I'm just going to rewrite that first equation again over here so that I can do my vertical addition here in a minute. And then I'm going to have this second equation times 2. And when I times it by 2, I have to multiply everything by 2. So that'll give me a 2x minus a 2y equals a 16. Okay, we draw our line and we're going to add. So that gives me a 5x, the 2y minus the 2y are going to go away, which is why we multiplied by 2. And then 6 plus 16 will give me 22. Have to get x by itself, so that gives me x equals 22 over 5. Everybody's dreaded fractions. They don't ever go away. Now we have to take this x and we have to plug it into one of these equations. I'm going to plug it into the second equation just because x is already pretty much by itself, and that'll make the problem easier. Again, you can plug this into either one of the equations and it will work out. I mean, obviously as long as you do your math right. But there is some choice in this stuff. Alright, so I'm going to subtract my 8 over here and add my y over here just so my y is positive. Now you have to remember your rules on fractions. If you don't, you need to go back to chapter 1. Excuse me. So 40 minus 22 is negative 18 over 5. And that is my y value. Excuse me again. So my ordered pair is not a pretty ordered pair, but it is an ordered pair. It is 22 over 5 and negative 18 over 5. So even when they're kind of yucky, you can still do it. Alright, let's do another one. Alright, example. We have x plus 3y equals 13, and we have x plus 4y equals 18. These are already written Nice, so we don't have to rewrite them, but we need one of our variables to disappear. So which of these looks like it's going to be easiest to get rid of, our x's or our y's? Probably our x's, because they both have a 1 out front, so we just need one of those to be a negative in order to get them to go away. So I'm going to multiply this whole top equation and multiply that by a -1. So if I do that, I'm left with negative x minus 3y equals negative 13. And then my second equation, I'm just going to rewrite underneath it so that I can do my addition. Again, you could have multiplied the bottom one by a -1 and your math would still end up working in the end. Okay, so if I add my x's, they're going to go away. If I add my y's, I get just one y left over, and that equals 5. So that was nice and simple. So now we have to take this and plug it into one of our equations. Again, it does not matter which one. I'm going to plug it into the second one just to be a little different. So anywhere there's a y, I need to do 5. So x equals a -2. So that means my ordered pair is a -2, 5. Okay, let's do another one. Let's do one where we finally have to do the first step. So we have 4x equals a -2y, and that's minus 18, and a -5y equals 2x plus 10. So there's our system of equations, but that's not written like ax plus by equals c. So we need to write them like that first. So my first equation, and I mean it's just moving stuff around. So my first equation will be 4x, and then I have to add over my 2y, and that equals a -18. My second equation, I'm going to need to subtract over my 2x, so that'll be minus 2x minus 5y equals a positive 10. So that is my system of equations whenever it's written correctly. Now I need my x's or my y's to go away. I am going to get rid of my x's because if you look, we have a 4 and a 2. We can just multiply our 2 by 2 to get 4. We'd have to multiply by a bigger number. We'd have to multiply both in order to get rid of these. So I don't want to do that. So I'm just going to multiply the second equation by 2. So let me rewrite my first equation. We have the 4x plus 2y equals a -18. Multiplying the whole second equation by 2, that'll give me a -4x minus 10y equals 20. Now I'm going to add. My x's go away. My y's become a -8y equals 2. And so from there, we're going to divide by the -8. We get y equals a -1 over 4. So now we have to take that and plug it into one of our equations, whichever one you want. I'm going to plug it into this top one. So that's 4x plus 2y equals a -18. 4x minus, because this is a negative times a positive, 2 over 4 will be 1/2, -18. 4x equals 36 over 2 plus 1 over 2. Again, if you need refreshers on your fractions, I recommend going back to chapter 1. And hopefully, whoops, that shouldn't be a 4, that should be an x over there. You get x equals a negative 35 over 8. So again, not necessarily a pretty ordered pair, but it is an ordered pair. And thus it is the solution to our systems of equations. But as we've seen, there are other options. I'm going to do one more where we're going to get an ordered pair, and then I'll show you what happens when you get no solution and infinitely many solutions. Let's do one more example though where we're going to get an ordered pair. We have an example, and our system is 2x plus 3y equals 6 and 5x minus 4y equals a negative 8. Okay, this is written correctly, but we need to get rid of one of our variables. 2 and 5 aren't multiples of each other, and 3 and 4 aren't multiples of each other. That means we're going to have to multiply both of our equations by some number in order to get this to go away. So the way that I make my decision on which variable then to get rid of is I look, both of my x's are positive, so instead of multiplying by a negative number at one of these, I'm going to see if my y's are different. And one y is positive, one y is negative. So what that means is I can just multiply by positive numbers across the board, and that makes it nicer. So I'm going to focus on getting rid of my y. So in order to get rid of my y, I need these to cancel out. So you have to think about what do they, like what are 4 and 3, what are they multiples of that are in common? So 3, you know, if you write out your 3's tables, you got 3, 6, 9, 12, 15. If you do your 4's, you have 4, 8, 12, and 16, and so on and so forth. But right there we have our 12's in common. So what do you have to multiply 3 by to get to 12? You have to multiply it by 4. So that means we're going to multiply this whole top one by 4. And what would you multiply 4 by to get to 12? You have to multiply it by 3. So you're going to multiply that whole second equation by 3. So our first equation times 4 will give us 8x plus 12y equals 24. Our second equation times 3 will give us 15x minus 12y equals a negative 24. So now we're going to add. So it gives us 23x. Our y's cancel, which is what we wanted. And then 24 minus 24 is going to give us 0. X is then going to be 0. So now we plug that into either one of our first equations. So I'm going to plug it into the first one. So 2x plus 3y equals 6. So when you plug in 0 for x, you're left with 3y equals 6. So y would then be 2. So my ordered pair would be 0, 2. So sometimes you do have to multiply both equations by something in order to get a variable eliminated. And that's okay. You just have to think through which variable then you want to eliminate. Okay, I am going to do 2 more examples because all of these have been consistent systems of equations. All of these have had both of the equations have had one solution. So let me remind you, if you get a false statement, then there is no solution. And the other option to that is if you get something that's always true, then there are infinitely many solutions. This is our inconsistent and our dependent systems of equations. You've seen these in 9.1 and 9.2, and now you're going to see them again in 9.3. So let's do an example. We have 2x plus y equals 3, and we have 4x plus 2y equals 12. So there's our system. We need to get rid of one of our variables. It does not matter which one. I'm going to get rid of my x's just because they're out front. So in order to do that, I need these to go away. So I'm going to have to multiply my top equation by a -2. So if I do that, I get a -4x minus 2y equals a -6. And then I'm just going to rewrite my second equation like it is. And then I need to add them. So my x's are going to go away. But if you look, my y's can now go away too. So that leaves me with 0 on the left-hand side because everything went away. And then I have -6 plus 12. That gives me a +6. Is that a true statement? Does 0 equal 6? No, this is false. So there are no solutions. So if you ever come upon something like that where you get another false statement, just like in 9.1, excuse me, 9.2, if you get a false statement, then that means there's no solutions. Okay, so let's do the last example. We have x minus 1/2 y equals 2, and we have y equals 2x minus 4. Okay, so far we have to rewrite these because the second one isn't written right. So I'm just going to do that right next to it. You have to write it as x, so I'm going to subtract my x over, so give me -2x plus y equals a -4. Now it's written the right way. Now I need to get rid of either my x's or my y's. Again, it does not matter which one, but I'm going to do my x's because I can multiply this first equation by 2, and it's gonna let me get rid of them. So that would give me a 2x minus y equals 4, and then the second equation just rewritten. And then I'm going to add them. So my x's are going to go away. Once again though, my y's can go away, so it's going to leave me with a 0 on the left hand side. And then if I look, I have 4 minus 4, which also gives me 0. So I have 0 equals 0. That is an always true statement. And so when you get an always true, there are infinitely many solutions. Again, most of the problems you're going to work are going to be like the first ones we were doing, which were the consistent problems, where we have an ordered pair as a solution. but you will see one of each of these where you have no solutions and infinitely many solutions. Your homework is exactly like these, so I'm obviously not going to just open them up and do them because I think you have ample examples to go off of. So good luck on your homework and good luck on your quizzes.